Hi, my name is Ekishore. I am from CSC AML B section. Today I am going to explain about design and implementation of a transistor-based amplifier circuit from three elements of electrical and electronics. Here are some profiles of EC, like EC1, EC2 up to EC6, and here are from up to EC12, and some course outcomes up to ECO6. Now I am going to explain the abstract of this project. The main abstract is design and implementation of a transistor-based amplifier circuit. This study explores the design and implementation of a transistor-based amplifier circuit to demonstrate its principles, performance, and practical applications. Amplifiers are essential in modern electronics, enabling the amplification of weak electrical signals for use in communication, instrumentation, and signal processing. This project focuses on the single-state common emitter amplifier, chosen for its simplicity and effectiveness in achieving significant voltage gain. The design process involves selecting appropriate components, including the transistor, resistor, and capacitor, while considering parameters such as gain, bandwidth, and input or output impedance. Circuit simulation tools are employed to verify theoretical predictions, optimize component values, and ensure the stability of the amplifier under various operating conditions. A practical prototype is constructed to validate the design and compared measured results against theoretical and simulated performance metrics. Key performance parameters such as voltage gain, frequency response, and distortion are analyzed. The study highlights the impact of transistor biasing, load impedance, and coupling capacitors on overall circuit behavior. The results demonstrate the importance of precision in component selection and the trade-offs between gain, linearity, and bandwidth in amplifier design. Project overview. Here we can see the project overview of design and implementation of a transistor-based amplifier circuit. The project aims to design, implement, and analyze a transistor-based amplifier circuit, demonstrating its functionality and practical applications in electronics. Amplifiers are integral components in various electronic systems used to enhance signal strength for processing, transmission, and output purposes. Objectives Objectives of designing and implementing a transistor-based amplifier circuit. It understands the fundamentals of amplifiers and explores transistor characteristics and also design an effective amplifier circuit. When on understanding the fundamental of amplifiers, it gains a deep understanding of the principles and working mechanisms of transistor-based amplifiers, with a focus on their applications in electronic systems. In Explore Transistor Characteristics, it analyzes the behavior of transistors, amplifications, including their operating regions, biasing conditions, and gain characteristics. Here we can see optimize biasing techniques, enhance circuit stability, simulate the circuit, construct a prototype, evaluate performance matrices, troubleshoot and optimize, bridge theory and practice, document and analyze results, foster innovation. In optimize biasing techniques, implements appropriate biasing methods to ensure the transistor operates in the active region for maximum linearity and stability. In enhanced circuit stability, it addresses factors like thermal stability, feedback, and load variations to ensure reliable operations under varying conditions. Stimulate the circuit. It utilizes stimulation tools to validate the theoretical design, predict performance matrices, and design and identify potential design flaws before hardware implementation. While constructing a prototype, it assembles the designed amplifier circuit on a breadboard or printed circuit board for practical testing and evaluation. While evaluate performance matrices, measures key parameters including voltage gain, input or output impedance, frequency response, and total harmonic distortion to access the circuit's effectiveness. And we can see troubleshoot and optimize. In troubleshoot and optimize, it identifies and resolve practical challenges such as noise, distortion, and etc. In brief theory and practice, it develops a comprehensive understanding of a interplay between theoretical concepts and real world implementation. It also fosters practical skills in circuit design and testing. And we can see document analyze results, and also we can see foster innovation. Now I am going to explain my project prerequisites and requirements. In prerequisites for designing and implementing a transistor-based amplifier circuit. To successfully design and implement a transistor-based amplifier circuit, a foundational understanding of the following concepts, skills, and tools is essential. It is theoretical knowledge. The theoretical knowledge are basic electronics, semiconductor physics, transistor operations, amplifier theory, circuit analysis, etc. In basic electronics, we have understanding of voltage, current, resistance, and power, and also knowledge of we should have the knowledge of Ohm's law and Kirchhoff's law. In semiconductor physics, principles of semiconductors including doping and p-n junctions. In transistor operation, there are types of transistors and their operating regions like cutoff, active, saturation for BJTs, cutoff, uh, linear saturation for MOSFETs. Transistor parameters such as current gain, it is also known as beta, threshold voltage like Vth, and input or output characteristics. In amplifier theory, it explains about the concepts of voltage gain, current gain, and power gain. And also it also makes us to understand input or output impedance and bandwidth. It, it will also give us a knowledge of coupling and bypass capacitors. In circuit analysis, it gives us ability to analyze DC biasing circuits and AC small signal models. It also used to Thevenin's and Norton theories for circuit simplification. Requirements. There are amplification goals, signal characteristics, power supply, etc. In amplifier goals, it has gain, bandwidth, input and output impedance. In gain, it defines the required amplification factor. In bandwidth, it determines the frequency range of the amplifier needs to handle. In input and output impedance, it specifies the desired impedance levels for matching and source and load. In signal characteristics, it has input signal amplitude, output signal requirements. Input signal amplitude. It ensures the circuit can handle the input signal without distortion. In output signal requirements, it decides on the desired output levels. Power supply. In power supply, we have voltage and current and also efficiency. Voltage and current. It specifies the available power supply range. Efficiency. Means it optimizes for low power consumption if necessary. Component selection. Transistor type. Bipolar junction transistor and field effect transistors. Bipolar is also known as BJT, and field effect transistor is also known as FET. In bipolar transistors, it makes us suitable for high gain and current amplifications. And field effect transistor is preferred for high input impedance and low noise. There are passive components like resistors, capacitors, inductors, etc. Here is methodology of my project, like algorithm and etc. Algorithm for designing a transistor based amplifier. There are input specifications, output specifications, power supply, etc. And step 2, it chooses the amplifier configuration like common emitter, common collector, common base. Common collector emitter is also known as common source, and common collector is also known as common drain. Step 3, biasing design. It sets up the operating point. It chooses a biasing scheme for BZT and FET. Stabilizes the bias. Add resistors to ensure thermal stability and minimize drift. Here we can see the circuit diagram of this amplifier circuits, and you can see in right side you can see also, you can also see a calculation for this circuit, and this is observation table for that circuit. Here we can see results and discussion of this transistor based amplifier circuit. In the design and implementation of a common emitter transistor amplifier circuit, a series of observations, measurements, and tests are carried out to evaluate the performance against the theoretical expectations. And also we can see conclusions and future scope. In conclusion, the design and implementation of the transistor-based amplifier circuit, specifically a common emitter amplifier, has been successfully carried out with the following key takeouts. Here are some achieved voltage gain, frequency response, and thermal and bias stability. Future scope of design and implementing transistor amplifiers is expansive. Given the continued advances in semiconductor technologies, materials, and application specifics requirements. Integration and with by advanced semiconductor technologies. There are gallium nitride and silicon carbide, FinFETs, and nanowire transistors. Here we can see some references like microwave and RF design, introduction to solid state physics, a review of gallium nitride power amplifiers, and trends in CMOS RF power amplifiers. Thank you.